We present 3DRealHead, a few-shot 3D head avatar reconstruction method that can faithfully reproduce identity and facial expressions. Given 1 to 3 images of an actor during inference, our method generates a realistic 3D head avatar representation that can be driven by a monocular video, reproducing detailed mouth expressions. Current 3D head avatar approaches like head gap often struggle to faithfully reproduce the identity and facial expressions, despite having multi-view data or learned priors. Learning priors that capture the diversity of human appearances, especially for regions with highly person-specific features, like the mouth and teeth region, is challenging as the underlying training data is limited. In addition, many of the avatar methods are purely relying on 3D morphable model-based expression control, which strongly limits expressivity. Therefore, we introduce 3DRealHead, which overcomes these limitations through a novel expression control signal that is extracted from the driving video stream of the subject. Our method is based on a style UNet prior trained on a high-quality multi-view studio dataset. This prior is trained on the NAR-assemble dataset with additional adversarial losses. For animation, the UNet is conditioned not only on 3DMM-based expressions but also on mouth region features extracted from the driving video. These additional features enable the avatar to express facial dynamics beyond the capabilities of traditional 3DMMs, resulting in more lifelike and expressive outputs. To recover a 3D avatar of a subject with this UNet-based prior, we use a few-shot inversion process where we fine-tune the identity encoder as well as the last layer of the decoder. The expression encoder is fixed. Using a monocular driving video, the resulting avatar can be animated and rendered under novel viewpoints. We evaluate our method on both studio-based and in-the-wild data captures. Here we show a comparison against state-of-the-art methods that are based on a single image to reconstruct an avatar. Our method also only receives a single shot. As can be seen, our method faithfully recovers the identity of the subject, and in comparison to the other methods reproduces a high-quality mouth interior. Here we show a comparison based on in-the-wild video data. While Insta, Flash Avatar, and Splatting Avatar require an entire video to recover the 3D avatar, Cinshot and ours are only based on 3 images. Despite this difference in data requirements for the enrollment, our method achieves similar high-quality results with an expressive mouth region. We also show some ablation results. To achieve a high realism of the mouth interior, which is very person-specific, we provide a gradient-based input conditioning during driving. Without this conditioning, our method is still able to generate good results, however the identity is slightly changed. Instead of a gradient conditioning, one could also employ an RGB-based conditioning. While there is no qualitative difference in this shown scenario, the RGB conditioning greatly reduces the application areas of our method. As shown in the paper, the gradient conditioning can handle changes in the illumination and still produces high-quality outputs. Here we show an example where we modify the image used for inversion to reconstruct an edited avatar. This avatar can then be driven by the user with a monocular video. Finally, we show some novel view synthesis results. Thank you for watching.